Today in this unit, we're going to be starting a topic that's not normally covered in much depth in an algebra class, but we are going to go into this a little bit, the mathematics of finance. Now, this would be what I consider a very, very shallow introduction to the mathematics of finance for those that actually go into finance. And by the way, if you're wondering, well, what is finance? Finance, the people that go into finance, those are your bank officers, not the tellers, but the actual officers. Those are also investment brokers in some sense. Not all of them have studied finance. Finance is actually an entire degree you can get in college. There's different aspects of finance. There's the investing, there's borrowing. Finance is going to, at some level, get into some of the insurance stuff as well. It's a big topic. So this is just going to be just a small taste of it. Now today specifically is going to be the topic of simple interest, which you start looking at simple interest formulas back in, I don't know, 5th or 6th grade. So that part's going to seem familiar to you. But we're going to be looking at the more realistic side of it, not just what you would have seen, like I say, in the 5th or 6th grade. That not that it's not a real formula, the simple interest formula, but the way that it was taught and applied just doesn't actually fit reality most of the time. So, simple interest, definition, it's interest paid on the principal only, not on an accumulated interest. Now, I realize that if you're in my class, we just finished the exponential growth logarithm unit, and there we talked about compounded interest and continual compounding, which is part of the mathematics of finance. But that's not what this is. This is not on accumulated interest. It's referred to as just simple interest. To me, this is a great one to understand for when you take out a loan, whether it be like a car loan. Technically, this could be on a mortgage, which just as a side note, a mortgage is more complicated than just a car loan, not just because it's a bigger thing, but there's way more legal stuff involved with a mortgage. And I might talk more about mortgages later on. But what we're looking at here is, why do you pay the amount that you pay on your car loan? And car loans is probably the best thing to talk about when I'm discussing simple interest. And typically, a lot of times what happens with car loans is at some point you want to pay it off early. In fact, not on this section, but in one of the sections to follow, we're going to look at, hey, if I pay off my car loan early, what's the payment got to be to pay it off? Okay, well, it's going to involve the simple interest portion of the calculation, and so we'll get into that. So the mathematics today is not terribly complicated. As we go through this unit on the mathematics of finance, some of the stuff does get fairly complicated. When we calculate what's a mortgage payment going to be, it's a big formula. Later on, we're going to talk about annuities. Annuities, it's the idea of, here again, back in most math classes, most algebra classes, the problems given to you for compounding interest are something to the effect of someone takes $10,000, they put it into an investment, they get 2% interest for 5 years, compounded quarterly. How much do they have at the end? Okay, that's not necessarily a realistic scenario. Most people don't have $5,000 or $10,000 just sitting around that all of a sudden they can plop into some sort of investment. Most people, the way they invest, it's the slow and steady method. They put aside $50 or $100 a month for years and years and years, and they just keep doing that. That's called an annuity, which the calculation for then calculating, well, what's it worth, is completely different than just that really simple compound interest formula. And trust me, when we get to that formula, you're going to look back at the compound interest formula from our exponential growth unit and go, wow, that was way simple. Because the mathematics of finance are not necessarily easy, even though today you're going to kind of get a break on the first day. It's simpler on the first day here, what we go through. So like I said, here is that compound interest formula from our exponential growth unit. And in that case, you're getting interest on both the principal, the amount that you have in, and on interest you've already earned. And of course, you get this nice exponential growth curve when you do that. But that's not what we are talking about. We're talking about simple interest. And here's the formula for simple interest. Interest equals principal times rate times time, which should sound familiar to you. Again, that's taught in like the 5th or 6th grade. The first time you see it, for sure by 7th grade, you've seen that formula, which I would argue is too young because 7th graders have no interest in money at all. Some high school students don't either. But it should at least sound familiar to you. But in the simple interest formula, the interest is accrued, it means gathered up, or earned only on the current principal. Okay, so when you have a car payment and you're going to make that monthly payment, some of your money goes on the principal, some of it goes on the interest. How much goes on interest is based off of the period of time, 1 month. Normally people make their car payments every month, so it's 1/12 of a year. And how much is still left on the loan, left on the principal. Normally we say left on the loan in kind of the common way we talk about this. But when you're talking finance, you would say the current principal. How much is left in principal? What do you still owe? Well, if you graph that out, it's just a nice linear line. So it's actually, calculation-wise, it's a much simpler thing than dealing with this curve right here. So that's what we're talking about today, the simple interest. Let's take a look at a little calculation here. Calculate the simple interest earned on 1 year. So we're talking about 1 year on a $5,000 deposit that's making 1.5 annual interest. This is the 6th grade version of finance right here. This is exactly what you would have done back in 6th grade. So you did something like this. Well, you did, well, interest is principal times rate times time. Don't forget this entire unit. Your rate is always going to be as a decimal. So make sure you put that in as a decimal. And oh, it's going to be $75 of interest. Okay, there. Congratulations, you just got out of the 6th grade. That's not what we're going to be talking about, though. I mean, it could be this situation, but what are the chances of you putting money in and taking it out exactly 365 days later? I mean, that's what it is, 1 year. So literally, you know, so you put it in on January 18th, you took it out on January 18th the next year. When you start to think about that, this is not a realistic way of talking about finance. It's a great introduction for a 6th grader, but it's not the way reality works. But we are stuck with the idea that this time unit here has to do with years. So it's assumed to be in years, that time unit. So we have to deal with that what if they took it out on December 18th or December 22nd? Okay, they didn't take it out to go Christmas shopping. Well, then we have to tweak things a little bit. Okay, balance. Let's talk about this real quick before we move on. So what would the balance be after a year? Well, just getting used to the terminology. If you had put in $5,000 a year later, you had $75 in interest put together with it, your balance would be $5,075. Okay, so your balance then, from an investment point of view, is the principal plus the interest that you've made. Okay. Let's take another look at this one. $100 invested for $100 invested for 1 year at 2% interest. How much would have earned after a year? Again, welcome to the 6th grade. This is pretty easy right here. $100 times 1 year for our time times 0.02. And we're going to end up with, of course, $2. You should have been able to do that in your head. Okay. What if I changed the question, though? Instead of 1 year, what if I had said the first 6 months? Well, the logic here should be pretty simple to come up with. That, well, if you got $2, that's why I'm starting with easy numbers. $2 after a year, if I only did 6 months, well, it should be half of that, right? It should be just $1. You can probably come up with figuring that out on your own. But the way that I want you to approach this is, let your time unit be 6/12, half of the year. Because where we're going with this, again, has to do with, like, on a car loan. What if you took out a loan and you only actually needed the loan for 8 months, well, then it'd be 8/12. Okay, we don't want to get locked into this just being years, because the reality is it's pretty slim probability that you ever land on exactly a given year. Again, brought your money in on January 18th and you'll happen to just be there exactly 1 year later. Probably isn't reality in most situations. So we're trying to make this a little realistic. So we're going to tweak this time unit here. I promise you this, on my assessments, you're not going to get in nice even increment years. Not going to happen again. You're not in the 6th grade. We're going to be talking about fractional units of time. That's how I'm going to have you calculating this stuff. So, because then I can give you any unit of time. So 4 months, oh, it'll be 4/12. If I did it in days, well, then you do it out of 365. Okay, fractional units of time. This is how it's actually done. This is not how it's done. All right, so let's look at one dealing with days. Calculate the simple interest due, 45-day loan. So just a quick little loan, month-and-a-half loan on $3,500 with an annual interest rate of 8%. Okay, so we go through. The principal still stays the same. The interest stays the same. But we have a fraction of the time, because again, the formula is assuming this to be a year. Well, this is no longer a year. Since it's in days, I'm going to use 365. Okay, I know it's 365 1/4. Let's just stick with 365 though. That actually is close enough in banking, because if you go way past the decimal point when you do these calculations, it doesn't matter anyways, because we're talking money. It stops after the first 2 decimal places. So then you got interest is $34.52. If I ask you what the balance was due on that particular day, you'd have to add them together, $3,534.52. And that would be the balance due on that date. So I've actually done this before. I have taken a short loan out from a bank. I have taken it and said, this is what I'm borrowing. I will call you in a couple months and I'll pay it all off. And you actually have conversations with the banker. The banker will literally say to you, what day are you going to write the check for? And you'll have to answer. Was it today? Is it tomorrow? Is it the next day? Because the amount on the check will change based off of your answer. Which day? Because they're charging you interest by the day is really what's happening there. Okay? I'm assuming almost all of you will end up having that conversation at some point in your life. You'll have a loan. You'll be ready to pay it off. And you'll call the bank and say, hey, I want to pay off the loan. What's the payoff amount going to be? And they'll say, what day is the check going to be here? And then they'll calculate it for you. This is the reality of how things work. Okay. Simple interest charged on a 6-month loan, $3,000 is $150. Find the simple interest rate. Okay, so for some crazy reason, this person doesn't know what their interest rate is. I don't really like this question, but I know these things show up in a finance class, because if you took out a loan and didn't know the interest rate, or at least didn't ask or weren't told, you're not being a very responsible consumer. But I know these questions, like I said, show up in finance classes. In their case, let me explain why they would do this. They do this, but they do it from the banking side of things. They sometimes decide how much they want to make and then match the interest rate to fit it. Okay, so you got to actually think of this from the banker side of things, not from the consumer's side of things. All right, well, you've just set it up. This time, though, we know the interest. We know the principal. We know the fractional unit of time. And, of course, we need to solve for the rate. I'm assuming you would understand to divide by 3,000, multiply by 12, and then divide by 6. Now, not particularly in that order. Just somehow you got to get those 3 numbers to the other side. And, of course, you end up with 0.1, which is 10%. If the question is what's the interest rate, that's not the interest rate. You have to move the decimal 2 places to make it a percent. So here's something. Many of you in high school may have never dealt with this, but at some point you probably will deal with something called a certificate of deposit. So I want to explain what a certificate of deposit is about. Many of you have probably had what's called a passbook savings account. Okay, a passbook savings account. They literally, when I was young, there was a little book that looked actually kind of like your passport. A little book, and every time you'd put money in or take money out, you'd hand the book over to the lady at the till, and she would write in either how much you put in or how much you took out. Okay, so there's, even though nobody's writing in books anymore, they're still called passbook savings accounts. They're the basic run-of-the-mill. I open up a savings account, I can put money in there, I can take it out anytime I want. Because you can take it out anytime you want, they don't pay you much interest. See, the way banks make money, they take money that people have given them to invest, they then borrow that out so people can buy a house or buy a car, they collect interest off that money they borrowed out. But the kicker is they have to be able to have so much money literally in the bank. The federal government regulates this. In fact, there's a percentage. There's a percentage of what they have to have in order to operate as a bank. So the fact that a passbook savings account, someone could walk in at any moment and empty the account, they're not a reliable source of money for them to loan out to other people. They don't really like them, so they don't pay hardly anything. I mean, literally, you put $1,000 into a passport thing in a year, you're going to get, barely any interest. You're not even going to have $1 worth of interest. It's nothing. So what banks try to do is they try to encourage you to lock in your money for longer periods of time. And they do this with what's called a certificate of deposit. And they used to actually be these nice fancy certificates. They're not anymore. In fact, I don't even know if you get paper anymore. But they'd give you this nice certificate. And it would tell you how much money you put in. It would tell you what the interest rate was going to be as long as you left it in for the entire amount of time that you agreed on. The amount of interest depends on a couple things. How much money are you putting in, and how long are you leaving it? That last example where I said bankers would sometimes calculate the interest, that's exactly why they would do that. So that interest rate can change. In fact, you can negotiate sometimes with a bank. If you had a very large sum of money that you actually could just plop in for a while, you could actually negotiate a little bit and say, well, I'd like a little bit more interest in that, and you might actually win that one. The issue becomes, though, that maybe you've taken a chunk of money and said, hey, I don't think I'm going to need this for 6 months. Maybe you're a senior in high school and you've been saving for college. Well, you don't need that money till next fall. And so maybe you guys say, hey, I could go throw this in a certificate of deposit for 6 months and make 3 times the interest I'm making off my passbook account. That's great. Okay, so I would even recommend you do something like that. But if something happens, maybe your car breaks down and you're like, oh, you know what? I do need that money now. If you do what's called an early withdrawal, you take out before it was mature. The maturity date is how long you agreed you were going to leave it in there. If you withdraw part of your money or all of your money out of a certificate of deposit before the maturity date, you're going to pay an interest penalty based on the amount of what you withdrew. Okay, so you only pay the penalty on the amount you withdraw, not the entire amount. Please remember that. You only pay the penalty on the amount you withdraw. Okay, so here's an example. Suppose you invest $5,000 in a 1-year certificate of deposit that pays 3.5% interest. After 6 months, you decide to withdraw $2,000. Your interest penalty is a 3-month simple interest penalty. Okay, usually they'll tell you right on the certificate, they'll tell you what the penalty is going to be. It's typically not the entire period of time. It's a period of time, but not always the entire period of time. And so in this case, the period agreed upon penalty is a 3-month period of time on, again, only the amount that you're taking out early. Okay, so you do not use the $5,000 at all in this situation, only the $2,000. Okay, so what interest penalty would you pay? Well, you'd pay your 3.5%. So you're going to have, it's your simple interest formula. Here's our interest rate, here's our time, here's now principal. Even though I know that's the principal, that's not the number we're using. We're using this number, only the amount you take out. Rate times time times principal, $17.50 would be the penalty. And just so you know, most of the time they don't literally make you pay them out of pocket. What they do is they just subtract this amount from the interest that they're going to pay you, because you're still leaving $3,000 in there, and this $2,000 did make interest for 6 months. Okay, so they're going to make you, oh, by the way, though, you won't gain interest on that last 6 months. So it's, you lose out on that and you have your penalty. But you don't cough it up, they just deduct it from the amount that they're going to pay you. Maturity value. This term, future value is terms, excuse me, future value and maturity values, they're going to come up a lot in this unit. And a lot of times they're actually talking about the same thing. It's the point of view that you're looking at it from. Okay, when you borrow money, the total amount to be repaid to the lender is the sum of the principal and the interest. Okay, the amount that you're going to pay is the principal plus the interest. This amount to be paid to the lender is called the maturity value if it's a loan. Okay, so if you're borrowing money, this is referred to as the maturity value. But if you're the one doing the borrowing, which is what an investment is, when you invest your money, you're borrowing your money to somebody else. If you're the one doing the borrowing, then this is referred to as the future value, because you're looking at from the standpoint of an investment, what's this going to be worth later on? Okay, so you've got present value, and you're going to see this term again later on. Present value is what it is now. Future value is what it'll be later. This is from the point of view of you investing. If it's a loan, then we would call this the maturity value. It's going to still be more dollars than what you borrowed. So this would be the borrowed amount, and then the maturity value. If you're the one doing the borrowing, that's what an investment is. It's called the present value, and then it's going to be called the future value. So it's a little confusing. Same exact formula, it's just principal plus interest. It's just which point of view are you? Are you the banker or are you the person taking out the loan? But it's really the same amount, which it should be. Just a little bit of a vocabulary thing there. So calculate the maturity value of a simple interest 9-month loan of $4,000 at 8.75%. This is a really bad percentage. This is somebody with like bad credit right there. So I want to calculate the maturity value, this right here. Okay, for the maturity value, I need the principal, which I have. It's $4,000. And I need the interest, which I don't have. I have a period of time and I have an interest rate, which means I have, this is really a two-part question. I have to calculate the interest first, and then I'll come back and plug it in. For that, I then, of course, need my interest formula. So I'll use this, $4,000, 8.75% interest as a decimal, and 9/12 of the year, 9 months out of the year. Okay, so I'll calculate that, and then I'll substitute it in right there. Then I can add that $4,000 principal to get the maturity value. So that's all I'm going to do right there. I've got the amount is $4,000 plus $4,000 times my interest rate times my fractional unit of time. Now I'm going to show you something here, and I want you to remember this, because you're going to see this version of what I'm going to do here many times over. If we factored, we'll do a little mathematics here, if we factored out the $4,000, the principal, then the amount is going to be that $4,000. I'm sorry, this is going to get a little messy when I'm doing it this way. Plus 1, times 1 plus the interest rate times my fractional unit of time. Or as a formula, and that's where I'm going with this, as a formula, you're going to see this principal times 1 plus rate times time. This is a version of what's called the maturity value formula. Or, again, if it's a matter of point of view, it could be the future value formula. It depends upon your point of view. If you're investing, this would be the future value formula. Okay, I guess I had that number there. Sorry about that. Got ahead of myself a little bit. I'd like you guys to try one on your own. So please pause this video and give this a try. See what you come up with. Find the simple interest rate of a 4-month loan for $5,000 car if the maturity value on the loan is this. All right. Well, if this is the principal and this is the maturity value, so this is $5,000 here, this is $5,113.33, then it's pretty simple to figure out that this portion right here, that's got to be the interest. Okay, so I know that number. And I know the principal. So I can substitute principal there. I can substitute my interest right there. I know that it's 4 months, which is 4/12 of a year. So 4/12 is going to end up going right here. And from there we can again solve for that interest rate, which hopefully you came up with 6.8%. All right. Alternative method for calculating future maturity value is derived from this, and this is actually what I was just talking about with you a minute ago when I was scribbling. Here's that formula right here. So this is one we're going to use as we go through the rest of this unit on finance. It's sometimes called maturity value. It's sometimes called the future value. One of these two terms is the A, and it comes from taking and substituting this stuff in for the I, and then factoring out the principal. Put this in for the interest, factor out the principal, you get this set right here. Which, if you remember from our exponential logarithmic section, this is actually really close to something we did there. That this is then used to derive the one we did for the compound interest formula. That one was more complicated than this, but it was based off of this one. So it probably looks a little bit familiar to you. You probably feel like you've seen it before. That's because the compound interest formula was close to this. Okay, so let's take a look at this. Calculate the maturity value of simple interest. We've got a 12-month loan. Well, that makes it easy. It's just 1 year. So that'll be a 6% with a principal of $3,800. Okay, this is pretty easy to do then. We take my fractional time, which in this case is just 1, times the rate. I would do this, guys. Start here, multiply these guys, add it to 1, and when you're done, hit enter, times 3,800. Now, if you have a nice graphing calculator, you can probably type it in as exactly as shown. If you're using your phone or an older calculator, I would do it the way I just explained. Kind of work right to left. Otherwise, you might get the wrong answer. In fact, you should pause this and try it. This is the right answer. You should see if you can get that. You got to know your machine that you're using to do your calculations. Okay, what would the maturity value be if the same loan was paid off in 3 months? Okay, so this was the maturity value after an entire year. But again, that's not always realistic. Maybe they paid it off early. Paid it off in just 3 months. Well, then you just tweak the time unit, the fractional time. That's all that changes. And so it becomes then just $57. I want you to take note here. By changing the amount of time, by reducing the amount of time, it really dropped it. That's pushing $200 less by covering that. I'm going to speak to this again in just a couple minutes here. About paying things off early. I'm going to make a plug for that, even though I will admit personally I'm not great at it either. I try, but I can't always do it. Let's take a look at this. The maturity value of a 3-month loan of $4,000 is $4,085. What is the simple interest rate? Okay, so we're going to work this guy backwards. Let me walk you through this one. What you would want to do with this is go ahead and divide by the 4,000. Then, once that's gone, you would subtract the 1. So then the 4,001 would be gone. All that's left is these two. Then you could multiply by the reciprocal of this fraction, multiply by 12/3. On this side, it would cancel. And over here, you just multiply by 12/3. So there's my work there, a little bit at least. Divide by the 4,000, subtract the 1. This works too if you switch to decimal, and then just divide by the decimal. Do that last, though. You got to do it last. And you should end up with 8.5% interest. Or you could work it this way, and you get the same exact thing. So we've got these different formulas. My point with this is maybe you like this way more. Maybe you like this way more. I don't really care. Just pick one of them and use it if I ask you a question like this. Let's take a look at this. If you take out a car loan, you've got to understand that every month that you make a payment, almost all car loans have monthly payments. There are some that don't. They're called balloon loans, and I've taken balloon loans, but most car loans have a monthly payment. That payment is really in two parts, and I'm hoping you learn some stuff about personal finance right here, not just mathematics. The two parts are the principal, and I see I spelt that incorrectly, sorry. That's the wrong kind of principal spelling, but it's the principal and the interest added together, which is based off of the, now this is the interest part I'm talking about. The interest is based off of the outstanding balance. So you think about this. As you pay off month after month after month after month, the outstanding balance actually is going to get smaller. And since the interest is calculated with a simple interest formula, that means that the amount of interest being paid each month becomes less and less and less. Which then you might get to thinking, sorry, this is bugging me, I'm going to switch that. You might get to thinking that, well, then my payment should become less. Well, that's not exactly what happens. Because what the bank has done before they set this all up, they don't want your payment changing every month because that would just drive people nuts. They want to give you an amount and say, pay this same exact amount for the next 3 years, 4 years, 5 years, whatever. They tweak this. So at first you're paying less here, and later you're paying more here. So it's less here, then more and more here, then later on it's more here and less here. That's actually what happens. Now I'm going to show this to you in just a second here. We're going to go to an Excel document. I'm going to show you what that looks like. The outstanding balance refers to the portion of the original debt that has not yet been repaid. Because you pay some part of the principal each month, the outstanding balance decreases each month. The amount that you owe is going to be going down every month by a little bit. So let's look at an example. Let's say you have a 4-year car loan on a $10,000 car. The annual interest rate is 5%, which is pretty close to what most car loans are at. Actually, it might be a little low. The monthly payment for the loan then is $230.29. By the way, a little side note. In this unit on finance, we're going to eventually use the formula to figure out where this would come from. We're going to do the payment formula. It's a big monster of a formula, but I want to show you how it works. Find the amount of the payment that goes toward the interest and towards the principal during the first, second, and third months. Okay, so let me show you. During the first month, now remember, the payment's $230.29. So you had the full principal. With that interest rate, 1/12 of the month means I'm going to pay $41.67 in interest that month. So then what went towards the balance? Well, you take $230.29, take away what you paid in interest, and that tells you that I paid $188.62 towards the balance, or the principal. Second month, let's see, the second month's going to be different because now that I've lowered this $10,000 by this amount, that number is, of course, not going to be the same anymore. So the second month, it's only $9,811.38 is now the principal. I go through same calculation and you'll see, oh, the interest went down, which it should because you didn't have as much principal. To get the what did I pay on the principal that month? Well, you take the monthly payment, subtract the interest portion, and you're left with the portion that went into the principal. notice it got a little bigger. I paid a little bit more off on what I owe on this loan. And we could just keep continuing this. Well, I want to actually show you this. I'm going to turn this thing off here. I went ahead and put together an Excel document showing you exactly what's going on. And I only did the first 20 months, so it's not paid off. The loan is not paid off here yet. Here's that $10,000 at a rate. The time, it's 1/12 is what this is. So just 1 divided by 12. Gave him my interest, and then I subtracted this from 230 to give me the principal. There's the second month, so on and so forth. And I just programmed this Excel document to do this. Real simple. If you've taken a business class, I'm sure you've learned, or accounting, to run the formulas in Excel. But then I went and made a graph because I want you to see this. This is a graph of the interest paid each month. So as the months go on, this is how much interest is paid. Notice it's becoming less and less and less, which you can see that right here. It's becoming less and less and less. All of the payment is interest. But the principal is the opposite. The principal, as the months go on, become more and more and more. You can see that right here. So here's the plug I'm going to try to give you. Almost any person gives you personal finance advice is going to say, if you can, you can't always do this, but if you can, and this is any kind of loan, if you can make bigger payments at the beginning, think about that. What if I was making a payment that paid off this much of the principal way back here? Well, then of course I'd have less principal, but in that month I would have had to have paid less interest because the principal was less, which then means even more money goes on to my principal out of my payment. So you pay your payment plus some extra. Okay, so if you can throw an extra $25, $30 into this every month, this is going to be higher, which then as time goes on, this will end up being lower. And what happens is at the end of the loan, you actually end up paying this thing off way, way sooner than at the beginning, because you're paying most of your interest at the beginning of the loan. That's the point here. If you can pay more on your principal at the beginning and make this period of time not last as long, you can actually reduce by a lot of money. So I shouldn't be circling that. You reduce by a lot of money the amount you'll pay at the end of the loan. You could maybe end up, by putting an extra $25, $30, you might shorten the loan by 6 months, which saves you, of course, 6 months times this, a lot of money. So just a little plug there, something to consider as you go through life and as you go look at these things. All right, so your assignment, it is in Schoology if you're in my class. Have a good day.